What is the role of the compound PSP, which results from the summation of all the iPSPs and ePSPs that occur nearly at the same time in dendrites and soma? What is its role, be it depolarizing, hyperpolarizing, or silent? We studied in chapter 2 that the action potential is initiated at the axon initial segment because there is a lot of sodium channels, and these sodium channels have the lowest threshold of activation. All the synapses here, when they are active all together, the role is to open or not the sodium channels here. If they open the sodium channels, it means that the sum of all the ePSPs and iPSPs reaches the amplitude of the opening of sodium channels. So here on the left, there is a closed sodium channel, and if the PSP, so this is the sum of ePSPs and iPSPs, is of sufficient amplitude to open these channels, sodium ions go through and an action potential is initiated. So here the channel is open. Here is the recording. So we have the PSP here and here the action potential. When the amplitude of the PSP, which is the sum of ePSPs and iPSPs, reaches the threshold for action potential initiation, then there is an action potential. So it has to be above this threshold to immediately generate an action potential. If only a few glutamatergic synapses are active at the same time, or there is a lot of GABAergic synapses active at the same time of glutamatergic ones, the resultant PSP is not of sufficient amplitude to allow the opening of sodium channels. If you look at sodium channels in the left, they stay closed. And here it's shown that the amplitude of the PSP is too small to reach the amplitude of sodium channel opening, and we call the threshold of action potential. So there is no action potential. This means that though glutamate is released, all the synaptic current happen, propagation, summation, there is no effect. So you see that to get an action potential in a postsynaptic neuron, it requires a lot of glutamatergic synapses to be active at the same time, and not too many GABAergic synapses active at the same time as the excitatory ones. Following the activity of glutamatergic synapses, an inward current is generated and produces an ePSP. Following the activity of GABAergic synapses, an outward current is generated and produces an iPSP or no potential change. When both synapses are active, they produce ePSPs and iPSPs that add up in a spatial and temporal manner. If the sum is a depolarization of sufficient amplitude to open sodium channels, an action potential will be triggered at the axon initial segment. If not, there will be no action potential. Inward synaptic currents result from the entry of cations through glutamate receptor channels. They evoke postsynaptic depolarizations called ePSPs. Here the amplitude of the ePSP, V ePSP, equals the resistance of the membrane multiplied by the current carried by the cations. Outward synaptic currents that are carried by chloride ions, now it's an entry of chloride ions, of negatively charged ions, through GABA-A channels. It evokes postsynaptic hyperpolarizations called iPSPs. the amplitude of an IPSP results from the resistance of the moment multiplied by the current carried by chloride ions. Often, the equilibrium potential of chloride equals the membrane potential. So the current is very weak and even null, and there is no IPSP. It's what we call silent inhibition. Once they are initiated, EPSPs and IPSPs propagate upstream, but also downstream to the axon initial segment. They passively propagate along dendrites, and their amplitude, because they passively propagate, their amplitude decreases and their rise time lengthens. Because some charges are lost during the propagation, they go out of the membrane. While propagating, PSPs summate. They can summate linearly, and it means that the PSP sum equals the geometric sum of EPSPs and IPSPs when they are generated far away from each other. But they can also sum in a nonlinear manner, and the nonlinear summation says that the PSP sum is inferior to the geometric sum of EPSPs and IPSPs if these PSPs are generated at close locations on a single dendritic branch, because then they have an effect on each other, or at single dendritic location, but multiple times in a row. The resultant compound PSP will generate action potentials if its amplitude reaches the sodium channel opening threshold, or it will reduce the probability of evoking action potentials if it is hyperpolarizing or silent.